Hey everyone, this is Mustafa Ahmed, Embedded Systems Intern at Emertxe Technologies. In this video, I like to share you guys with my experience, the valuable insights, the learnings, and my journey at Emertxe Technologies as an intern. And also, last but not the least, the project which I made with Emertxe Technologies, which is washing machine. The goals of this internship include gaining knowledge in embedded C programming, learning the syntax, structure, and applications of embedded C as variant of C optimized for microcontrollers based systems, which is very crucial while you're getting in, stepping your step into the embedded systems programming. And then hands-on experience with embedded systems, like working directly with hardware simulation boards like PICSimLab as shown in the image. Configure parts, read sensors, control actuators, debug embedded systems, and whatnot. Build real world projects. Apply your learning by creating embedded solutions such as a washing machine controller, a mobile phone, and etc. etc. So, mine one was the washing machine controller. The topics discussed around this internship was the data types, the characters, the boolean, the floats, the double, the integers, and not only data types, the modifiers made be signed or unsigned, the qualifiers, the consts, the volatiles, and the loops, which is very important while you're working with embedded systems because the timers and the loops are a crucial part for your project. And then jump, then decision, then storage classes like auto, register, static, extern, and derived structures and unions, and user defined data types. These are important ones like enums, type diffs, arrays, and pointers playing an important role in throughout your C embedded programming. And functions, a reusable block of code, and a number of times it can be used like a functions and strings and macros. So there are four types of embedded systems. Once the first one is standalone embedded systems, then comes the real-time embedded systems, then comes the network embedded systems, then comes mobile embedded systems. So the very first one, the standalone embedded systems. The standalone embedded systems, it operates independently without needing a host system, such as a computer or an external processor, which directly displaying data or making changes on the connected device. That is independently working without needing a host system. The input is received through parts in the form of analog or digital signals, and after performing the required calculations and conversions, the output is shown on a connected device. If you take examples for this, there are various examples like a washing machine, a mobile phones, etc. Then comes your real-time embedded systems. Now, the real-time embedded systems are designed to produce outputs within specific time constraints, with a short span of time or a specific time constraint when it's provided to this embedded system. It works upon it, making them ideal for time sensitive tasks. If you take the types, there are two types: soft real time systems, hard real time systems. Deadlines are important but not critical. This is for soft real time systems. Tasks must complete eventually, even if you are not meeting a deadline. Example, computer audio system. Now, hard real time systems. Strict deadlines must always be met. Any delay can cause failure. Example, an aircraft control system, crucial for life saving. Then comes your network embedded systems. Network embedded systems involve programs operating within devices that are interconnected, typically managed by a microprocessor or a microcontroller. Now, as the name suggests, network embedded systems. these are managed by microprocessors or microcontrollers. So these systems rely on networks, which may be either local area networks, your LAN networks, or your WAN networks, wide area networks. As these systems are connected to each other on a single network, they are known as network embedded systems, and that is what makes them possible to manage by a microprocessor or a microcontroller due to this single network they all are connected within. For example, if you see an office or a tech park, security systems are typically examples where devices are linked through a centralized network and managed collectively. All the security systems of a particular tech park or an office are connected to a single network, and that single network is managed centralized, where a single person or a single host system can manage and make any changes and control all the security systems throughout the office or a tech park. Then comes your mobile embedded systems. Now, what is this? A mobile embedded system refers to portable devices that operate using embedded technologies. Mobile, the name suggests, a portable device that can operate using embedded technologies. Your mobile is also an embedded system, by the way. So, despite having limited memory and features as compared to higher end computers, their ease of portability makes them widely useful and accessible. And that is exactly why we have our mobiles, a portable device, always with us. Example, their mobility, of course, is what makes them mobile. Example, laptops, calculators, or mobile phones, or any handheld computer which is portable. Now, let us explain you for the last but not the least and the most interesting part of this, the project. So first and foremost, let's look into the project requirements. The project requirements involved when I was working upon this, I had to be vigilant about them. The first one, this project focuses on simulating a washing machine using PICSimLab, aiming to replicate real-world washing machine functionality in a virtual environment. And if you know little about embedded systems, PICSimLab is what let us do that. And second, using various switches in the keypad to do the operations on the washing machine. Of course, when you are simulating it, even if it is in a virtual environment, let us have it uh, as much as possible to look and work as a real world example. Then comes the third one, using CLCD for displaying options and time left to complete the process. Using timers for tracking time left to complete the selected process, etc., is what the important stuff we'll be learning and doing in the project. 4. Using motor for representing the ongoing process and using the buzzer to indicate door status and program completion. So the tools used in this internship were MPLAB IDE for the environment and XC8 Compiler and PICSimLab. The XC8 Compiler to make the file, then to make it work in PICSimLab. We'll look into it further in our project. So MPLAB XID, it's a free cross-platform integrated development environment, as you all know, for programming like PICSimLab, DSPIC, AVR, and SM and SAMCOM microcontrollers, and it provides powerful features, querying, debugging, simulation, project management, whatnot. Like if you are into this, you'll know the importance of MPLAB XID. Then comes XC8 Compiler, specifically for 8-bit PICs and AVR microcontrollers, high performance and supports integration with MPLAB XID. That's the reason I use it here. Now, coming to PICSimLab, the most important and the interesting part which I learned in this internship. So it's a graphical simulator designed for simulating PIC microcontroller based circuits and interfacing them with real or virtual hardwares. So it actually allows users to test and debug embedded applications without physical having hardware, supporting integration with compilers like MPLAB XC8. I was able to do that as smooth. And now let's take a pause here and go and look into